first go over significant figures. We're going to go over significant figures, how to determine the correct significant figures that you have inside the problem. Second is significant figure with calculation, so adding, subtracting, as well as multiplying and dividing, and scientific notation, with one last exercise for you guys to try out at the end too. Okay, so on to the first section. So significant figures. So the first rules, we'll go over the rules that you guys will go over in class or have already. And the first one is all non-zero numbers are significant, are significant. So here you can see that there's the 7 and the 3 are your significant numbers. Real red numbers are significant. So 1.675, all those numbers are significant. You would count these as 4 significant figures. This, you have 2, but there's a 0 between it, so then you would count it as 3. Okay. On to the next slide. Your second rule is that interior zeros, so zeros that are in between your numbers, your real numbers, are significant. So like earlier, you have 0 right here. This is a significant 0, as well as these two, which are between the 7 and the 6. So the red numbers are also significant in these two numbers. Your third rule is that leading zeros to the left of the first non-zero number, are not significant. So like you can see here, the 2 zeros before the 8, those zeros don't count. So this is one significant figure. All these zeros here, I'm not going to count them. I think it's like 7. They also do not count. So you only have 3 significant figures for this number. Questions? Okay. So now is your significant figure rules with trailing zeros. So that means any zeros that follow the number, like the significant number, like a 1 or a 2 or a 3. You can categorize them like this. So your trailing zeros after or before your decimal are significant. So anything after this decimal and your significant number, which is 45, they are significant, so you will count them. So this would be 4 sig figs. The 0 after 4.67 would also be counted, so this is also 4. The ones between, so like earlier we said they're interior, so this would be counted, so this is also 4. And this would be 3. Actually, this would be 6. No, 5. Counting wrong. 5 significant figures. And that's because you count this 0.
The 2 zeros after the decimal words are also significant.
Yeah, so you'd count them as well. Yeah. So right here, the trailing zeros with no decimal, which really just means like there's like no end to it, they're ambiguous. So if you have 5,600, they're ambiguous. You can't really tell if it's 2 sig figs or is it 4. If you have 5,600 with a decimal, that means you have 4 significant figures because there's like a definite end. Or continuation in this case. There isn't really a defined one for the 5,600 without a decimal. Okay, so we're going to do practice now. If you're able to, I'll give you a minute to write these down. And then we're just going to go over it, and then you guys can practice on the next one, okay? So the first one is, I want you guys, we're going to underline numbers that are significant and circle the numbers that are not significant. Let's do this one together, and then the next one is a similar one, but you'll be counting. So if you guys want to tune in while I'm doing it or walk me through it, then you guys can, just let me know. So the first one is, they gave us, we have units, so meters, and you have 0.0020. Which numbers are significant?
The 2 and the 0.
The 2 and the 0.
Okay. And these are insignificant, right? Because they're before and they're not after the first non-zero. So that's correct. So what about B? Can you guys tell me the significant numbers?
All of them.
Okay.
4 sig figs.
So this would be 4. You guys can, if you guys want to tell me how many sig figs there are, you guys can tell me as well. So C, you have 675. Which numbers?
Ambiguous? Is it ambiguous?
It isn't. So it's not ambiguous because there isn't a 0. So if I gave you 6750, this would be ambiguous. This would be ambiguous.
What does ambiguous mean?
It's basically uncertainty.
Oh, okay.
So
Yeah. So it just means there's an uncertainty, like you don't know where the end is.
Oh, okay.
So
Yeah. So if I gave you 6750 with the period, this would count as 4 sig figs.
Okay, I guess I thought because when you kind of gave Angelina the 8 lions,
Mhm.
we're using meters. Is that why it will be?
Yeah, it is. So we have an actual, like a unit of measurement,
Okay.
like from the SI, instead of like counting numbers. So the lines are counting numbers basically. So you can say like you have 78 books. It would be infinite.
Okay.
Yeah. So 98.7890. Can you guys tell me which numbers are significant?
All of them?
6. Yeah.
6.
Yeah. It would be all of them. So you have 4, 5, 6. So you have 6 sig figs.
For the
Okay.
6750, the one that you said ambiguous, I thought it would be like I think it might be wrong, but I thought it was 3 significant figures because I thought the 0 was like a placeholder.
Oh, yeah. So the 675 is 3 sig figs. This one though is an example. Sorry. Yeah. So the 6750, this 0 right here is ambiguous. So if you look in the previous one right here, those 2 zeros after the 56, they're ambiguous because there's no implied decimal. They're trailing. Yeah.
But then you said the 675 are significant then.
Yeah, they are significant. So that's why you have 3 significant figures for it. Okay. You guys good? Can we go to the next slide? Yeah? Okay. So this one, I'm going to give you guys a minute, 2 minutes. Let me know when you guys are done writing them down, and we're going to put you guys into breakout rooms to do it, okay? So your task is to tell me how many significant figures are there in each number. Sorry, I'm just going to pause. Tell me how many significant figures are in so the first room, just one person tell me how many significant figures in A?
4.
4. So we just go down the line. Room 2, can you guys tell me for B? If anyone is confused on why we have 4, let me know. Oh shoot, can you guys see my writing?
Okay. That was 5 for B. Oh, I'm sorry.
Yeah. Okay, so B is 5. Yes.
Yeah.
C for room 3. Or someone, yeah.
Okay. On number C, 3 significant figures.
Okay, yes, so there's 3 significant figures. Can room 1 tell me how many there are for D?
For D is 3.
Okay, I will call a different person now. Kelvin, can you tell me how many significant figures for E?
Yeah, it should be a 5.
Okay. Nick, can you tell me for F?
Nick says 3 significant figures.
Yes. Okay. So is anyone confused on why the answers are the answers they are? Questions? No?
No.
Okay, so we'll go on to the next one. So you guys are going to go into your rooms again. I'll give you guys till 7:25. 3 minutes? 4 minutes? Enough? Actually, we'll go to 7:26. I'll give you guys a minute to write this down. You guys are going to round each number to 4 significant figures. Hey guys. Okay, so we'll go same as earlier and go down the line. Group 1, can you guys tell me what you guys rounded your A to?
156.9.
1 point.
Oh, 15. I got 156.9.
Okay, 156.9. Yeah. Okay, that's right.
Oh, okay. I thought we were supposed to write in scientific notation.
Up to you. You can leave it like this, or you can write it as 1.569. 10 to the, what did you put it for?
Negative, no, positive 2? Or it's
Negative 2.
Oh, it's negative 2.
Oh, wait. That's positive 2, sorry.
Oh, okay.
I get it confused too sometimes. I'm just like, wait, okay.
Can you
So-
explain that why?
That's actually in the following slides. We're gonna go over
Okay.
scientific notation. So don't worry, guys. We're gonna get there. So that's why you guys don't have to put in scientific notation.
Okay.
For B, can someone tell me what they put?
We put 4.780.
4.780. Okay, that's right. When you look at 3, it's less than 5, so you don't have to round. C, group 3.
Is it 10.00?
Yeah, it is. Okay. D, group 1, someone new. Or someone new in general. Oh,
I
someone.
put 7.634 times the power of -5. I'm not sure if that's right.
So you did 7.634 times
And
10
then
to the
-5.
-5. Okay, so if you count 1, 2, 3, 4, 5. Yes, that's correct. Okay, so E, let's go with a different person. Okay, Gladys, can you tell me what you put for E?
I put 6.850.
Okay, that's right. Anyone confused or have any questions why these are the answers?
For letter D, we can also write 0.00007634 is fine.
Yes, you can also write it like that.
I have a question. Whenever the arrows move to the right, the 10 to the power, it would be negative, and when it moves to the left, it would be positive?
Yes.
Okay.
So yeah, think of it almost like when you're doing, like you're following the number line. If you go to the right, it's the opposite of a positive, so it's negative. That's how I think about it. Okay, so we're going to the next problem, next section. So next section is significant figures with calculation. So we're going to go over adding, subtracting, multiplying, dividing. So rules to remember. The first one is, in multiplication or division, they're the inverses of each other. So the results, what that means is that your significant figures goes with the one with the fewest. So an example, I won't solve. So if we do 5.4 times 3.69, your answer, I'm not going to do the calculation, but your answer should have 2 significant figures. Because you're going with the number that has the least amount of significant figures. So this is for 1. So for 2, when you're doing addition or subtraction, you should line them up. That's really helpful. And it goes, or you don't have to, it just goes with the one with the least number of decimal places. So that's if I'm kind of similar to the multiplication, but in this case, we'll do 3.5679 plus 45.1. What you'll go to is you're going to go to the first decimal place after the, so you'll go x point x. So you go to this decimal place and not all the way to the 4th decimal place after. Good. Okay, so we're going to do problems. I'm going to send you guys the screenshot of this problem so you guys don't have to write it all down in a rush. And we're going to put you guys into groups, and you guys are going to do them.
How do you calculate the 9.5? What is the?
Yeah, I was just gonna go over that. Yeah, it was a little, but what it just means is 9.5 divided by 4.970.
Oh, okay.
Yeah, the colon means division. Okay, so for A, Alexa, can you tell me what you got?
For A, I got 1.84.
Okay, 1.84. Oh, Nick put his answer too. That is correct. And that is because right here you only have 3 sig figs. Pro tip for chemistry students now is whenever I'm doing word problems, I like reading through it and underlining or drawing an arrow to how many sig figs I have for each one. So it's just helpful for when you're comparing and you're reading a problem that you know one is 3 sig figs, one is a 4, so then you can put like final answer, just make a note of it, final answer should be like 3 sig figs. For B, can you tell me what you got, Kelvin?
Yeah, B at 0.033.
It was 0.033. Yes. Okay. You put it like this. I'm gonna write the alternate option is you can always do scientific notation, even though I didn't ask you to. One of them you kind of want to put it in because it's such a big number. So for C, can someone tell me what they got?
I got 0.0034.
0.0034. Yes, that's correct.
Scientific notation 3.4 times 10 to the negative 3rd power.
Yes, that's correct. Okay. For D, can someone tell me what they put? Someone who hasn't gone yet. I sound like a teacher. I don't want to sound like a teacher. D, you can type it in if you want as well.
It's 73.0.
73.0. Okay. That's the correct answer. So I think it was like the original answer was 72.9, like 5 or something like that. And since we want 3 sig figs right here, you have 3 versus the other ones. You're going to have to round. You'd look here, you have to round this up, which means you have to round the 2. And that's why you get 73.0. For E, can someone tell me what they got for the answer and then we'll do it?
I got 391.3.
91.3. You guys didn't see my work earlier that I was doing. My bad. I didn't realize it was frozen. So this was what I did. So I labeled that there's 3 sig figs right here. Because there's 3 sig figs right here, I put 3 sig figs for the final answer for the multiplication part. and then I added it. From here, it was originally 2.9, so that's why you round it to this answer. And that's how you get 391.3.
So for the
Okay.
final answer, shouldn't it be 3 significant figures?
No,
It's the decimal.
because yeah, so your final answer is with addition. So you have to apply the addition rule, which we were looking at earlier. And it was that addition is you do with the fewest decimal places. So can someone give me their answer for F?
I think I'm wrong, but I'm gonna give it a shot.
Okay.
I got 1.1 times 10 to the fourth power.
No, that's right. I got the same answer.
Oh, okay.
Yeah. So you do the subtraction first, and your answer, the answer you get is 63.8, and you divide it by 0.0059. Then you get a big number. You get a big number like 10813.559. Right? So then now you would do your sig figs, your scientific notation to get it to the right place, and that's how you get 1.1 times 10 to the fourth. Any questions?
Nick put, I guess, a scientific, never mind.
Oh, he just corrected it. Yeah, 1.1 times 10 to the fourth. Yeah, that's the right answer. Okay. Do you guys want me to clarify anything, or we are good to go to the next slide? Next slide. Okay. So the next slide is scientific notation. This is the one we're going to go over now. So here are examples of scientific notation. What you'll see is you move it. Do you guys like me drawing these like looped arrows, or would you guys prefer me to like just underline the decimal places? The places.
Either will work.
Looped? Okay. I like the looped one. We'll go 1, 2, 3, 4, 5 to the right. So that is a negative number. So that is why the answer is 5.6 times 10 to the fifth. Negative fifth, 5. From here, you'll go 1, 2, 3, 4, 5, 6. And that is why this is 6. And this is 5. And this is why it's 10 to the 6. Left is positive, right is negative in this case. Your 78, you can just go 7.8 times 10 to the 1. First power. Okay, next slide. So we have one more problem after this. It's up to you guys if you guys want to stay and finish it. But these are the ones that we're going to do. Would you guys prefer to go into breakout rooms, or do you guys want to stay here and just do it? Just one person needs to
Just stay
answer.
and do it.
Stay here.
Okay.
Stay here.
Okay. Three more minutes should be good. It's finished by 8. Maribel, can you tell me what you got?
Is it 6.7 times 10 to the 5th power. But I didn't know if it was a negative or a positive.
So remember, to the right, right, is negative.
Okay,
To the left
positive.
is positive. So think of a number line. You have 0 and 1 and -1. To the left, it's the opposite. Just remember it's flipped. That's how I think about it. If it helps you,
Uh-huh. Okay,
flip it.
okay.
Flip sign. Yeah. So for B, can you tell me what you got, Angelina?
4.59 times 10 to the 7th power.
1, 2, 3, 4, 5, 6, 7. 7th power, positive, and that is correct. The sign right here is -5. Sorry.
I'm sorry, Michelle. Can you repeat the answer for the letter A? I'm sorry.
A, it is 6.7 times 10 to the -5.
Okay, cool. Thanks.
Yeah. So C, can someone tell me the answer, Alexa or Din? Whoever one unmutes first or types it. So if it's in scientific notation, put it in the whole in the entire number.
I got 0.00167.
Okay, so it goes 3 to 0.00167. So let's say, so the decimal was here, it goes 1, 2, 3, and that's correct. Okay, that's the right answer.
Quick question.
How about, yeah,
If we don't put the 0 in front of that decimal, would it be considered wrong?
depends on your professor.
Okay.
That is the case of your professor. Usually I always say put a 0 before your decimal. There's no harm in it. It doesn't count for a significant figure anyway.
But it doesn't make the problem wrong either, unless the
Yeah.
professor.
It's just a holding
Yeah.
place.
It's just a holding place. So unless, if you do a 10.0, that would change the answer because it's 3 sig figs.
Okay.
But if it's a before, it doesn't count.
Okay. Thank you.
Yeah. So can someone give me the answer for D? For 9.8 times 10 to the 4th.
Nick gave 9.8000 points.
Okay.
Wrong way.
Wait. To the 4. So if it is a positive number, it moved, it moved left. Oops. Okay, there you go. 9.8. 4, you have 3 zeros after, so it's 98,000. And that's right. Okay, so we'll do the last one. 6.7. Okay. Last exercise. This is the last one. I gave you directions. We'll 5 minutes to do it, or 8, 10, up to you guys. If you guys finish first. So for the first one, for A, can someone tell me their answer?
I got 1.3 times 10 to the 7th power.
Okay, that's correct. And that's because you had gone from this 134,808,45.24 number, and you just move it. And that's 7 decimal places. Okay. For B, can someone else give me their answer? Someone different? Anyone new? Up to you guys.
It's 5.93 times 10 power 4.
So you got 5.93.
Yes.
10 to the 4th. I got 5.92. Maybe it could have been an error on my side. So you did the inside. So you divided 28.7 times 10 to the 5th. Since it's division, you're only keeping 3 sig figs, correct? What was your sig fig number?
59280.01153.
Oh, 59280. I do the multiplying. 28.7, 10 to the 5th, divided by 48.533. I got 59135.
I got the same thing as her, 59135.
Yeah, so 0.02153. What that means is that the sig fig for this would be 5.91, 10 to the 4th. And then you would add the 144.99. They both end in 2 decimal places after. So your final answer should be 5.92. 10 to the 4th. So that could have been a number error. Maybe you inputted something. But I didn't get 5.93. Okay, so C, the last one. What did you guys get?
I got 7.7 times 10 to the 6th power.
So this one says round to the correct sig fig. Okay, 7.7 times 10 to the 6, right?
Yes.
Okay, that's the correct answer. Because your final one, you're supposed to end with 2 sig figs. The other number was just a whole number, so there wasn't any difference. Yeah, so that's it for this workshop.